Good day, students. How are you all doing? Trust you're doing great. Welcome to your first chemistry lesson via this platform. This lesson is specifically for the SS2 science students of Sleek Angels International School. Due to the constant lockdown imposed by the government, in order to avert the spread of coronavirus, it is necessary you utilize this opportunity by doing a personal revision on previous topics, keeping in touch with academic updates online, and also try as much as possible to develop yourself in terms of skills. This will make you outstanding when we resume. Alright, now I will be introducing the third term scheme of work to help you know the topics to be treating this term. Scheme of work for third term. First topic will be oxidation reduction reaction, also called Redux reaction. The second will be the ionic theory, and then we'll go ahead to look at electrolysis, hydrocarbons, and alkanols. These are the topics for the term. Now, let me give you the lesson objectives. Lesson objectives are those things you're expected to know at the end of the lesson. By the end of the lesson, you should be able to define oxidation and reduction reactions, define oxidizing and reducing agents, calculate oxidation numbers of elements, use oxidation numbers to name inorganic compounds, and finally, write and balance redox reactions. Alright, these are the lesson objectives. Now, let us quickly go into the topic for today, oxidation reduction reaction, also called redox reaction. Oxidation reduction reactions happen around us all the time. They range from the burning of fossil fuels to the action of household bleach. In industry, we obtain most metallic and non-metallic elements from their ores by the process of oxidation or reduction. Many important redox reactions happen in water, but not all redox reactions occur in aqueous solution. Although many important redox reactions occur in water, the combustion reactions in the presence of oxygen take place in air. Now, let us look at the definition of oxidation reduction reaction, also called the redox reaction. This involves the transfer of electrons from one atom to another. Take that again. This involves the transfer of electrons from one atom to another. It then means electrons are moving from one to another. Now, let me remind you that an atom contains three subparticles, which are protons, the neutrons, and the electrons. The protons and neutrons are in the nucleus of the atom. The protons are positively charged, while the neutrons have no charge. Now, the electrons are revolving around the nucleus. That means they are outside the nucleus, revolving around the nucleus. They contain negative charges. So it means that electrons are negatively charged. Okay, so the transfer of electrons from one atom to another is called redox reaction. From the diagram, you're having an atom X and Y. Now, electron is moving from X to Y. It means X is giving out electron, Y is taking the electron. So, X that is losing the electron is oxidized, whereas the Y that is receiving is reduced. Now, you will be wondering, how come what is gaining is reduced? Don't worry, in course of our learning, you'll get to know why. But take note that when an atom loses an electron, it is oxidized, and when it gains, it is reduced. Alright, now let us look at specifically the meaning of oxidation and reduction reaction. Now we'll be defining oxidation and reduction based on 1. The addition and removal of oxygen. 2. The addition and removal of hydrogen. 3. The loss or gain of electrons. And finally, the change in oxidation numbers. Let us now look at the first one, addition and removal of oxygen. Oxidation reaction is a reaction which involves the addition of oxygen. When oxygen is added, it means oxidation has occurred. Reduction involves the removal of oxygen. That means when you remove oxygen from a reaction, you are performing reduction. Now from the equation there, you have copper oxide plus hydrogen. Copper oxide is CuO plus hydrogen gas produce copper and water. So the one by your left hand side called reactants, left hand side product. I've taught you this in first term. Now, if you look at the blue line from copper oxide to copper, you would observe that at the end, the product is copper. The oxygen was removed. So that process is called reduction because oxygen was removed from copper oxide. Now the red line is having hydrogen to water. Now hydrogen at the end of the reaction is having oxygen. That means oxygen was added, and from our definition, that is oxidation. The same thing applies to the second equation or reaction. Iron oxide and hydrogen. At the end, you have iron and water. Now, from the blue line is showing that oxygen was removed from iron, so it is reduction. The red line is showing that oxygen was added to hydrogen. That means it is oxidation. So oxidation reaction is a reaction which involves the addition of oxygen. Reduction involves the removal of oxygen. Now for removal and addition of hydrogen. Oxidation involves the removal of hydrogen, while reduction involves the addition of hydrogen. Okay, here oxidation is removal of hydrogen, reduction is addition of hydrogen. Now the equation there, having ammonia plus bromine will give us nitrogen and hydrogen bromide. Now ammonia contains nitrogen and 3 atoms of hydrogen. So NH3 is ammonia, bromine is Br. Now at the end of the reaction, when they reacted, they produced nitrogen and hydrogen bromide. Now, the ammonia lost 3 atoms of hydrogen to produce just nitrogen. That means removal of hydrogen, that is oxidation. Now, at the end of the reaction, bromine is having hydrogen attached to it. That is reduction reaction, gain of hydrogen. Alright, the third one is loss and gain of electrons. Loss and gain of electrons. Most times they tend to define oxidation reduction reaction in terms of loss and gain of electrons, because this really shows the chemical processes that occur in uh, electrons gaining and losing. All right, now I've been able to reduce it to what we call oil rig. Oil rig, oil there is for oxidation, rig is for reduction. Oxidation is loss of electrons, reduction is gain of electrons. Okay, oil rig, oil rig, oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Oxidation and reduction must occur together. They cannot exist alone. So it means as oxidation is taking place, reduction is following the same time. Okay? Because there is no way you will stretch your hand to give something to somebody and there is nobody there to take it from you. So that's what happens there. Now, for an atom to lose, that means it's donating electron, another atom must be willing to accept. Alright. Now, you have, from that diagram, you have elements A and B, and then A is yellow, B is purple, and you're having a pink color, on top showing electrons. All right. Now A is donating electron to B, so A is losing electron. That means it is undergoing oxidation because it's losing electron. Now, when it loses electron, it becomes oxidized. All right. Whereas B is accepting the electron or gaining the electron. Now, when it gains the electron, it becomes reduced. Now, this is a point where I will explain to you why an element is gaining electron, yet it is reduced. Now, electrons are negatively charged. All right. Now, when atoms gain more negative electrons, electrons are negative charge, when they gain electrons, they tend to become more negative. So to become more negative, you have to move from positive going down to negative. That's what it means. So you're moving, for instance, the atom maybe contains +2. As you add more electron, because it's negative, so it's pushing down, it go to +1. You add more, it goes to 0. You keep adding, it goes to -1, another -2. So it becomes more negative. That's why they say it is reduced, because it is coming down to negative numbers. All right. Let me remind you again. Oxidation, the oil is the loss of electrons. The rig, reduction, is the gain of electrons. Now, let us look at oxidation number. Oxidation number, this is an indication of an atom's richness in electrons. It shows the number of charges the atom would have in a molecule if electrons were transferred. Remember, we are looking at transfer of what? Electrons. That's oxidation, remember. Oxidation, reduction, reaction. Now, oxidation number gives an indication of an atom's richness in electrons. How many do I have? How many does A have? How many does B? Like that. That's what it shows. Now, it shows the number of charges the atom would have in a molecule if electrons were transferred. I've taught you this in SS1. Now, I told you that to know the oxidation numbers of the first 20 elements. I'm very sure you can remember the first 20 elements. And then I made you make a periodic table. I've also taught you periodic table. And then I told you that the periodic table is divided into 8 groups. Okay. Now elements in group 1, they have oxidation number 1. Oxidation number is also called valency. So elements group 1, oxidation number 1, 2, oxidation number 2, group 3, oxidation number 3, group 4, oxidation number 4. And then from 5, I told you can get the oxidation because they are non-metals now. You can get the oxidation number from subtracting the group number from the total group. So have 8 groups. So 8 minus 5 will give you 3, but it will have a negative oxidation number because they are non-metals. Alright, so it will be 8 minus 5, 3, that's minus 3. Group 6 will be 8 minus 6, that's 2 minus 2. Group 7 will be 8 minus 7, that's 1. The oxidation number will be minus 1, and so on. Take note, in free elements, that is elements that are not combined with another element, uncombined state, that they are standing alone, each atom has an oxidation number of 0. So if you have oxygen alone in a reaction, the oxidation number is 0. You have hydrogen alone, standing alone in a reaction, the oxidation number is 0. Number 2 point is, in calculation of oxidation number of an element in a molecule, the sum of the oxidation numbers of all atoms in a neutral molecule must be 0. Now, if you have a molecule is the combination of elements. Now, you could have one or you have more than one element making a molecule. Now, if you have, for instance, CO2, CO2 contains carbon and oxygen. This point is saying that add the oxidation numbers of the elements and equal to what? 0. Alright, so it will be C plus O equals 0. That's what it means. Now, if you're looking for C, to be C plus the oxidation number of O, then equals 0. Then you get it. The last one is that the sum of the constituent atoms in a polyatomic ion must be equal to the charge on the ion. The sum of the constituent atoms in a polyatomic ion must be equal to the charge on the ion. Remember, an ion is an element with a charge. Could be a positive charge or a negative charge. Polyatomic ion is an ion that contains more than one element. An example is your sulfate. Sulfate is SO4. So you have sulfur and oxygen. That's more than one element. So it's a polyatomic ion. And now the charge is 2 negative, 2 minus. So it's saying if you're getting oxidation number of any element in a polyatomic ion, equate it to the number of the charge. So if I have SO4 2 minus, now the oxidation, to get the oxidation number of S will be S plus 4 times O equals to minus 2 and not 0. That's what this means. Okay, I hope you got that. Now, how do we calculate oxidation number? That's what I just explained. Let me just do an example. Determine the oxidation number of C in H2CO3. C in H2CO3, that is hydrogen carbonate or carbonic acid. What do you do first? Add the elements, the oxidation number equal to 0. So 2, open a bracket, H, 2 in front of it because you're having 2 hydrogens, plus 1 of C plus 3 of oxygen because you have 3 oxygens equals 0. Now 2 oxidation number of hydrogen, because hydrogen is in group 1, so the oxidation number is 1. So it will be 2 times plus 1 plus 1, because it's C we are looking for, so you write C, just C, and not the oxidation number, plus 3, open a bracket, minus 2. Oxidation number of oxygen is minus 2 because it belongs to group 6. So 8 minus 6 will be 2, and the oxygen is a non-metal, that's minus equals 0. So plus 2, that's 2 times 1 is 2, plus C, plus 3 times minus 6 is 3 times minus 2 is minus 6 equals 0. Now you have 2 plus C minus 6 equals 0. Move 6 over to the other side, and the 2, so if 6 moves to the other side, it becomes positive. So the minus becomes positive, so plus 6. Then the plus 2 will move to the other side, becomes minus 2. So 6 minus 2 will give us 4. Therefore, the oxidation number of C is plus 4. That's how you get for any compound atom or molecule. Alright? Now, if this were to be a polyatomic ion, assuming it contains minus 1 up on top of the oxygen, it will no longer be equal 0 but might equal minus 1. Okay? So now, let us look at change in oxidation number. We can also define oxidation and reduction in terms of change in oxidation number. Oxidation occurs when the oxidation number of an atom increases. Now, when you see a reaction and then you calculate the oxidation number of the atom in that reaction and it increases, know that oxidation is happening there. Now, why reduction occurs when the oxidation number decreases. So oxidation is increase in oxidation number, reduction is decrease in oxidation number. Look at the figure you have there. It's looking faint, but just try to look at it. Now you have the first equation is hydrogen plus chlorine. Of course, hydrogen plus chlorine will give you hydrochloric acid, as hydrogen chloride. Now hydrogen is standing alone, so the oxidation number is 0. Chlorine is also standing alone before reaction, the oxidation number is 0. At the end of the reaction, both of them combine to form hydrogen chloride. That's together. Now there is a bond there, ionic bond. Now from 0, hydrogen in hydrogen chloride, the oxidation number of hydrogen is plus 1. That of chlorine is minus 1. Alright. You can also solve if you want to solve with the method I gave you. Now, so from 0 to plus 1, there is an increase. So that is oxidation. From 0 to minus 1, there is a decrease. So it is reduction. The same thing happens to check the second equation. Sulfur plus oxygen to produce sulfur 4 oxide, SO2. Now, sulfur standing alone is 0 oxidation number. Oxygen alone is 0 oxidation number. At the end, they combined to form SO2. Now, sulfur oxidation number in SO2 is plus 4, while oxidation number of oxygen, of course, is minus 2. So, sulfur increased from 0 to plus 4. Oxidation is happening there. Then from the oxygen 0 to minus 2, reduction is taking place there. Now, this is very important because for most reaction, if you're giving a reaction, it is very easy to know if that reaction is redox or not by the change in oxidation number. So when there is an increase, you say oxidation is happening here. When there is decrease, we say reduction is happening. All right. Now let us look at examples of redox reaction. These are some of the examples of redox reaction. First one, zinc plus copper sulfate produce zinc sulfate plus copper. At the end, there is change in oxidation number. Zinc was 0 here. Now at the product side, it's combining with zinc sulfate, so it becomes 2. Copper here was 2. At the product side, is standing alone, so it's 0. So there is decrease and there is increase. The same thing happens to the second equation. Zinc plus copper That's zinc plus copper ion, copper 2 ion, produce zinc 2 ion plus copper. There's change, reduction, and uh, uh, increase in oxidation number. The next one is copper plus silver nitrate, Ag is silver, produce copper sulfate and silver. There is also change in oxidation number. The next one, the same thing. If you look at these reactions, you will notice that there's either an increase or decrease in the oxidation number based on what I taught you. All right. Now, let us quickly look at oxidizing and reducing agents. Oxidizing and reducing agent. Just to remind you that redox reaction involves the transfer of electrons from one atom to another. Now, where one atom is giving out the electron, the other one is receiving. Okay, so what then is oxidizing agent? Oxidizing agent is an element or compound that gains electron. It gains electron. So that element that is always willing to collect is an oxidizing agent. Take note. It gains electron. Why? Reducing agent is an atom or compound that loses an electron. So that one that is always giving out is a reducing agent, because it's giving out, so it will be called reducing agent. I'm doing the giving, so as I'm doing, I'm reducing. Now the other one, oxidizing agent, is the one that is receiving. Let me always collect, I don't want to give. So the oxidizing agent is receiving. So X loses electrons, Y gains electrons. That's what is happening in that figure. So X is oxidized by Y. So when you lose, you oxidize, but you're reducing agent. Now, when this other one accepts or gains electron, it is reduced by X. All right, but it is the oxidizing agent. So in definition, you say oxidizing agent is an element or compound that gains electron and itself reduced, while reducing agent is an atom or compound that loses electrons and itself oxidizes. Okay, now let us look at, oh, this is another way to explain oxidizing and reducing. Now from the figure, you can see X going to Y, electron transfer. So X is losing electron and is oxidized. Y is gaining electron and is reduced. Take note from what I explained to you. Now X loses electrons here, Y gains electrons. X is oxidized because it's losing electron, Y is reduced because it's gaining. I had explained what it means to be reduced when you're gaining. X is the reducing agent because it's the one losing electrons. Y is the oxidizing agent because it's the one gaining electron. So take note from the definition I gave you. Now another way to know is X increases oxidation number. Now when the oxidation number of X is increased at the end of a reaction, you know that that is a reducing agent. So it then means that reducing agent will have an increase in oxidation number after the reaction, while oxidizing agent will have decrease in oxidation number after the reaction. So Y decreases oxidation number. Alright, take note, these points are very important. The element that donates or loses electron is called the reducing agent, Y element that gains electron is called oxidizing agent. Okay, now this is an example. You have aluminium just neutral atom plus silver ion. You can see the positive sign on top, so it's an ion. We give both of them reacted to produce aluminium ion, that's 3 plus silver atom neutral. Now the numbers on top are the charges. Okay, so neutral, of course, I told you element standing alone is 0. Now this one is supposed to, the silver is supposed to be 0, but because it's having a charge, it is +1, just one charge, so it's +1. At the end, you have aluminium, the other side is having a charge of +3, and then the silver becomes 0. Now aluminium changes from 0 to +3. Now there is an increase. There is an increase in oxidation number. It means oxidation is happening there. So aluminium is oxidized, but it is a reducing agent because the oxidation number increased. Remember, reducing agent will have oxidation number increased at the end of the reaction. Now for silver ion, silver changes from +1 to O. Silver Ag changes from +1 to O. That means it's reducing. So it is reduced. Silver is reduced, but the oxidizing agent, because the oxidation number was reduced at the end of the reaction. So for this, you should be able to identify any redox reaction that comes your way. Alright, just take note of the oxidation number. If there is an increase, you know. If there's a decrease, then you can state if it is redox or not. Alright, now this, let us look at an assignment I've been able to draft that for you to remind you to keep to your, to bring to remembrance all that I have taught you now. Now try as much as possible to answer this assignment without going back to listen to this video again. Alright, now we've been able to look at a definition of oxidation reduction reaction in terms of addition of oxygen, in terms of addition of hydrogen and removal. Also looked at the loss and gain of electrons, and then oxidation numbers, the increase, and then the decrease. How to know that. We look at some redox reaction and how to identify them. So this assignment, attempt this assignment and submit via my email address or WhatsApp number. Alright, number 1, okay, the assignment is give one word for each of these descriptions. Give one word for each of these descriptions. 1. The chemical process in which there is a transfer of electrons. What is the name? Just write the name. 2. The chemical process that occurs when the oxidation number of an atom decreases. This is decreases. Give the name. 3. The chemical process that occurs when an atom loses electrons. Put the meaning, the name. Then 4. The substance that loses electrons in a redox reaction. The substance that loses electrons in a redox reaction. Then finally, number 5, the state that indicates the relative richness in electrons of a substance. Attempt this assignment and submit via my email address janeforgod2008@yahoo.com or WhatsApp number 0809071369. Take that again. My email address janeforgod2008@yahoo.com or WhatsApp number 0809071369. Alright, now should you have any challenge, any question at all you want to ask, you can ask them through my WhatsApp number. When I see them, I will attempt to you. All right. Now, thank you for listening and watching. I hope you learned something new today. Please do not forget to follow the NCDC directive on how to avoid the spread of coronavirus. Take care of yourself. I miss you all. Enjoy the rest of your day. Bye-bye.